Hello, Algebra 3 trig students. I am sorry that I'm not here today, but I hope that we can work through these notes okay and not give you too many issues. So a lot of these notes we talked about yesterday. There's a few parts that we didn't, we talked about Friday, but some parts we did not talk about, which I want to cover here. Some of them that we did talk about Friday, I'm going to glance over. If you want to fill in a full part of the notes, you can go ahead and do so, but I'm just going to be highlighting certain examples. So I hope you're able to follow along. Okay, the first thing is the difference of squares, right? This happens anytime we have a subtraction of two perfect squares. So in this case, it's a squared minus b squared. It's always going to factor the exact same way. It's going to be a and b in each parentheses, and one's going to be positive and one's going to be negative, right? Because we go through and multiply a times a gives us a squared. A minus b gives us negative ab. We can get a positive AB, they're going to cancel out. So for x squared minus 9, it is going to always be something like x minus 3 and x plus 3. Okay, for a perfect square, to factor that, all right, this would be an example of it's going to be a plus b squared. So in this case, the square root of 36 we know is 6. The square root of x squared is going to be x. And this is simply going to be 2 times 6. So it's going to be x plus 6 squared in both cases. Okay. Really, though, the difference of squares ones are really the most important one. Perfect square ones are not too important that you pick out. It's probably just simply easier to factor and identify the pairs that work together. With difference of squares, they can look differently or come in different shapes and sizes. Okay, so we have 4x squared. We know that this is a perfect square because 2x times 2x gives us 4x squared. And we also know that 25 is a perfect square because we can do 5 times 5. So using our difference of squares rules, it becomes 2x minus 5 and 2x plus 5. Okay? So looking at our next example that I want to look at, it's going to be example 6 in your notes, which is 4x to the 5th y minus 9x to the 3rd y cubed. Right, so the first thing we can do is we can factor out a y and an x cubed from each one, right? Because that's going to be our GCF. So when we factor out an x cubed y from each term, what we're left with is 4x squared minus 9y squared. Okay, and when we do that, now this becomes a perfect square, right? So the x cubed y is going to stay, and then we can factor this 4x squared minus 9y squared. So the square root of 4x squared is going to be 2x, so we're going to put 2x in our first spots. The square root of 9y squared is going to be 3y, and we are going to make one positive and one negative. Okay, so that's just a quick review of a difference of squares. Now we are going to look at the sum of cubes and the difference of cubes. Now this one is different and it can get very confusing, so I'd make sure please star these in your notes. All right, I am going to ask you to know these and how to get these. The nice thing is they look pretty much the same. So they are always going to factor into a binomial and a trinomial. So this will have 2 terms and this will have 3 terms. So to start out, it is simply just going to match up with what you have here without the cubes. So x cubed minus y cubed, our first factor is going to be x minus y. Right now we can fill in, so the first is going to be x squared, mainly because when we do x times x squared, it gives us this x cubed. The last term is going to be y squared. Again, when we do y times y cubed, y times y squared, it gives us the y cubed. Now, the middle term is going to be a little different or tricky. It is always going to be the opposite sign of what we started with. So if we started with a negative, it's always going to be a positive. And then it is just simply going to be xy. And our last sign is always going to be positive. Right? So when we do this, so here, we are going to take the cube root of each one of these, and that's what's going to fill into our parentheses. So the cube root of 8x cubed is going to be 2x, the cube root of 64y cubed is going to be, is going to be 4y. So that takes care of our first parentheses. And now we can fill in the signs. It's going to be opposite, and the last one's always going to be positive. So now this is going to be this first term squared. So we're going to do 2x times 2x, which gives us 4x squared. The last term is going to be this term squared. So we're going to do 4y times 4y, which is 16y squared. And for the middle term, we just multiply these two things together to get 8xy. Right? If we wanted to, we could then multiply this out to check it. But that's how it's going to factor. Right? For the next one, it starts out the same way. Our first term is always going to match up with whatever we have. Just drop the cubes. And then we're always going to have x squared to start. We're always going to have y squared at the end that's positive. And multiply the two terms. And again, it's going to be opposite. So again, please star these formulas or equations as a reminder. So when we go to factor this, we are going to take the cube root of each term. So the cube root of this is going to give us 4x. The cube root of this is going to give us 5y. And now that we know those two, we can go ahead and factor. The first one is going to be 4x plus 5y. Again, keeping the signs the same. First term is this squared, so 4x times 4x gives us 16x squared. 5y times 5y gives us 25y squared. And then we multiply these two things together and change the sign to get the factored version. Okay? So let's look now at example 8. Okay, this is a difference of squares example because both of these are perfect squares. So when we take the square root of that, we get square root of 81 x to the fourth is going to be 9x squared. The square root of negative y to the fourth is going to be y squared. So it turns into 9x squared plus y squared, and then minus y squared. So the tricky part here is then we have to realize that this is going to be a perfect square also, which is going to then factor into 9x squared plus y squared, and then 3x minus y, and then 3x plus y. Okay, so go ahead and stop this video and then move on and watch the next one to finish up our notes.